Okay, so with this problem, I want you to know that for machine design, if you're in a machine design course or if you are studying for the professional engineering exam, this is going to be something that is crucial for you to gain a foundation of. This is, these problems, they take a minute to work through, but they're fairly simple once you understand how to solve them. And I really mean that, okay? So they say there's 4 equations that you need, and we're going to use a couple of them here. So there's 4 equations that you need in the PE exam, and then in the machine design course, and arguably mechanics of materials course, or deformable bodies, whatever they call it at the university or institution where you're studying. So with this, I've written out a few problems for us to start solving through, and I will have to ask you to forgive me because there's some additional notes written on here from explaining things during a study session. Excuse me. So we're going to determine the maximum shear stress in the beam. We have forces of 2,000 pounds here and at the end. We have a reaction force here and here at point A and B. So we're going to take a look at a rectangular cross-section beam, and then an I-beam and a square shape cross-section beam, and then a T-shaped cross-section for a beam. So I am going to walk you through this first one and then a little bit through the second, and then you guys can solve this on your own from the point that I get you to. So if you're using the Shigley's design for mechanical engineering, I think it's called Shigley's Machine Design book, that is a great one to use. All right, let's take a look at this equation we have for shear stress. It's tau, or the shear stress, equals V times Q, which is the first moment of area, over I times B. For this rectangular cross-sectional area that has a whole section in it in the middle, we find the area. So I'm just going to see if I can bring this in closer so you can see it. Okay, so right here I'm saying this is 1 inch times 3 inches for this top section's area, plus 1 inch times 3 inch for this bottom section's area, plus 1 inch times 1 inch, and 1 inch times 1 inch for each of those sides. And so then we get an area of 8 inches squared. That's awesome. So now we're going to look at what our y value, or our neutral axis in this vertical direction is. And we're going to take the area for this top section up here, right? So I just calculated that here, it was 3, and multiply that by what this location up from, we're going to say this plane that we're calculating from is this bottom portion right here, okay? And so it's 2.5 inches up until the midpoint. So I'll come down here and show you. So this would be 1 inch, 2 inches and a half. So this area would be at this y portion is 2.5 inches. Is that midsection or the centroid of this top area as far as the y component is concerned. So we say multiply that area of that section times that y component, where the centroid would be for that part of the area. And then we do that for each of the sections. And we divide by the overall area, which was 8 inches. So then we get that the y neutral axis is 1.5 inches away from this bottom portion, which is right here. So that is the neutral axis as far as the y component is concerned. Now, we have the inertia component here, and this is for the given cross section. So you can look this up in a chart, what this I value would be, okay? And for this one, it's 6.667 inches to the fourth, and that's based off of, this is 1 inch. Each of these is 1 inch, so 3 inches by 3 inches with a hole in the middle comes out to 6.667 inches to the fourth. Double check this, please. You should always double check everything that I do and calculate the values for yourself. So 1, you learn it, and 2, you don't trust that I get everything correct, because I make mistakes from time to time, especially if I'm hand calculating, okay? So I might just be saying that so that you'll work it out, but work it out, okay? All right, at the neutral axis, which is this axis right here, right? So if I were to balance this, what does that neutral axis mean? Okay, so like for this pen, for example, it's where that centroid is, basically, if you'll think of it like that. It's where you would balance that area in the y direction, okay? So at the neutral axis, we have the Q value, which is our first moment of area. That is equal to the area, overall area, which was 8 inches squared for this one, times the y value, which is that neutral axis in the y direction, and it came out to be 1.5 inches. So then we have 12 inches to the third. What does that mean? Inches to the third. Well, we said it's the first moment of area, so it's basically, if we were gonna try and rotate this beam, this section, this slice of the beam, we're gonna rotate it, it would rotate about that point, based on the area, okay? Not necessarily the mass, but we're saying the area. So think of it more as like the area times that distance right here, or I think in textbooks they usually explain it as looking from this centroid, how far away is this component, or the other way, how far away is that component. But